Okay, question number 5 says name the following compounds. 3 compounds are given to you, A, B, and C. Which one of them is alkane?
A.
The A is alkane. So the alkane was hydrocarbons, which you have only single bond between the carbon. And only in the A, you have only single bond. In the B, you have the double bonds. So this one is alkene. And on part C, you have triple bond. This one is alkyne. Yeah. We have not studied about the naming of the alkene and alkyne yet. So we only answer part A of this question. So name the following compound. So I want to name this compound. But you can see it's not the straight chain alkane. It is branched alkane. So I have to find the longest hydrocarbon chain. So it's very important to know what is the parent chain. So most of the students, when they want to name this compound, they make mistake and they take this one as the longest chain. Okay, so 1, 2, 3, 4, 5, and then they consider this one as a branch. Okay, so this is not correct. Since you have longer chain of the hydrocarbon here. So look at this one. If I choose this one to be parent, it is actually the longest hydrocarbon chain that I can have here. It's not written straight, but no matter. The carbons must only connected to each other to be considered as a parent. So now the blue one, it has 1, 2, 3, 4, 5, 7. So this is correct parent chain here. So I choose the blue one to be the parent. This is my parent chain. Okay. Now I have 2 branches. One is here, the other one is here. Okay, both of them are methyl. But when I name the hydrocarbon, I must mention the location of this branch. That's why I need to number the parent chain. And as I have told you, we have to number it from the side which the branch receives a smaller number. For this example, if we number it from the top, 1, 2, the branch receives number 2. But if I number it from the right side at the bottom, it becomes number 1, number 2, number 3. The first branch is on number 4. So obviously I have to number it from the up because the branch receives a smaller number, number 2. So it's number 1, 2, 3. Okay, this one is 4, this one is 5, and this one is 6. Now I have find the parent chain. I number it correctly. Now it's the time to write down the name of that. So in the first part, we have to write the name of the branches that we have. I have only one type of the branch and it's methyl in the second and the third position. So I have to write on the second and third position. Both of them are methyl, so I must write dimethyl. Then I have to name the parent. The parent, alkane parent with 6 carbon is hexane. Okay. So this compound is 2,3-dimethyl hexane, and it's a very important example because it shows you that when you want to find the parent, it's not necessary to be written straight. So it can be like this, for example. But still, this one is the longest chain of the hydrocarbon in this compound, and we have to choose that one as a parent. I move to chapter review, question number 15. Okay, these questions. It says name the following molecules. So when you look at these molecules, all of them are alkanes. because you have only single bond between the carbon. Okay, so let's start from part A. In the part A, you don't have any branch. You have a straight chain of the hydrocarbon. So when you have a straight chain of the hydrocarbon, you only need to count the number of the carbons that you have here. We have 1, 2, 3, 4, 5, 6, 7 carbons. And alkane with the 7 carbons is heptane, because hepta means 7 and this is alkane, so it becomes heptane. Okay, so the first one was very easy. But in part B, you don't have this straight chain hydrocarbon, you have branched alkane. So you have to find the parent. So it's very clear that the longest chain is this one. Okay, so the longest chain has 1, 2. Okay, here a carbon is missed, so you can write it. Okay, here must be carbon. Okay, and this is CH2. Okay, correct your text. So here it must be CH2. It's connected to carbon. This carbon is connected to CH3, CH3, CH2. Okay, and this carbon must be written here. So it's connected to the carbon CH3. This is the correct molecule. Okay, so this is the longest chain in this compound. Now I have to find the branches. I have 4 branches here, a methyl here, a methyl here, methyl here, and the methyl here. So there are 4 branches, all of them are methyl. I have to number the hydrocarbon. If I number it from the left side, it becomes 1, 2, and the branches are in the position 2. If I want to number it from the right side, this is carbon number 1, this is carbon number 2, and the branches are on carbon number 3. So that's why I number it from the left side, because the first branch receives a smaller number. So it becomes 1, 2, this is 3, this is carbon number 4, this one is carbon number 5, and this one is carbon number 6. Okay, so the position of my branches, one of them is in the second position, the next one is also in the second position, the next one is in the fourth position, and the last one is also in the fourth position. And all of them are methyl, so I have 4 methyls, tetra methyl, and the parent has 6 carbons, so it's tetramethyl hexane. So the name of these alkane is 2,2,4,4 tetramethyl hexane. Any question here? Okay, so if you don't have question, let's move to the last one. Again, this one is alkane. You have only a single bond between the carbons. You must find the parent hydrocarbon or the parent chain. Again, this carbon must be written here. So here you have carbon, it's bonded to CH3, and it's bonded to CH3 here. Okay, so but you know that how is that one? So this carbon is actually must be written here. Anyways, the longest chain of the hydrocarbon is this one. This is the longest chain of the hydrocarbon. It has 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons there. But also you can choose this one as the longest chain. So they are exactly the same. Look at these carbon that you have here. What is connected to that? On the right side, CH2, 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 CH3 is connected here. Okay. At the top, CH2, 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 CH3 is connected. So it means these two groups on the right side of this carbon and at the top of these carbons are exactly the same. So you can choose either of these one to be a part of your parent ion. But I personally prefer to choose the one which makes my molecule straight, which makes my parent to be appears in straight format. So I choose this one to be the parent. No matter which one you choose, both of them are correct and you will get the same answer. So what are my branches here? I have one methyl here and the next methyl here, and I have this pretty long branch here. From which side I have to number? It's very clear that I have to number it from the left side. 1, 2, because the branches appears to be in the position 2. But if I number it from the right side, it becomes 1, 2, 3, 4, 5. The branch appears to be on the fifth position. So I have to number it from the left side, which the first branch receives the smaller number. So this is carbon number 1, 2. This one is carbon number 3, carbon number 4, carbon number 5, 6, 7, 8, 9. So here in this molecule, I have two types of the branch. The first one is methyl. I have two methyls here. One is here, another methyl is here. But what is the name of this branch? You can see this branch has 4 carbons. And the alkane with 4 carbon is butane. But when it becomes branch, it converts to butyl. Okay. So the name of this branch is butyl. So you have two type branches here. One of them is methyl, the other type is butyl. Now we have find the parent, we have find the branches, we numbered our parents, so it's the time for the name these molecules. We have to start with the branches, and we have two branches. When you want to write down the name of the branches, you have to look at their alphabetic priority. The B, butyl, comes before M, methyl. So at the first, you have to write the butyl. It's in the fifth position here. So you have 5 butyl. And then what do you have? On the second position, you have 2 methyls. So I have 2, 2. Both of the methyls are in the position. So you are not allowed to write only 1, 2. Both of the methyl are in the second position. So you have to write 2 2's here. So 2, 2. Because you have 2 methyls, I write dimethyl. And then the name of the parent. What is the alkane with 9 carbons? 9 becomes nona. So this one becomes
Nonane.
nonane. Okay. So this molecule is 5-butyl 2,2-dimethyl nonane. Okay. Let's go to the next question. Question number 16. It says give the complete uncondensed structure. So the uncondensed structure is a structure that we also have to show the bond between the carbon and hydrogen. So give the complete uncondensed structure or formula of each of the following alkanes. The first one is decane. So how many carbons are there in decane?
10 carbons.
10 carbons. So I have to write a straight chain of the alkane with the 10 carbons. And between each carbon, we must have only the single bond because it's written A and E at the end and it's alkane. Okay? So I write the answer here. So question 16, part A. I want to draw the decane. Okay, so I must have 10 carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 carbons. All of them are connected to each other by the single bond. Now the only things that I have to add to these molecules is the hydrogen. The first carbon at the left side, it needs 3 hydrogens. The second one needs 2 hydrogens. The next one needs 2 hydrogens. So they need 2 hydrogens till the last one. The last one needs 3 hydrogens because it has only one bond with the carbon. Okay. So the last one needs 3 hydrogens. It has one bond here, so it needs 1, 2, 3 more bonds. So this one is the uncondensed structure formula for decay. Let's draw the molecule in part B. In part B, you have 3,3-dimethyl pentane. So when you want to draw the molecule, so in this question, the name is given to you and it asks you to draw the molecule. Start from drawing the parent. The parent is pentane. So it means in the alkane, in the parent chain, I have 5 carbons. So here I draw 5 carbons, 1, 2, 3, 4, 5. Then I will add the branches which is given in the question to this parent. It says 3,3-dimethyl. It means in the third position, and again in the third position, you have methyls. You have 2 methyls in the third position. So I go back here. When you want to add the branch, number your parent which you have drawn, no matter from which side. So I choose to number it from the left side. 1, 2, 3, 4, 5. And the molecule says 3,3-dimethyl. So in the third position, I have to put 3 methyls, one at the bottom, one at the top. You know that the methyl is CH3, but the question asked me to draw the uncondensed format, so I show the bond between the carbon and hydrogen. This is CH3 and CH3. Okay, so now I put the branches on the parent. The only things I have to do is to add the hydrogen to the rest of the carbon. The first carbon needs 3 hydrogens. The next one needs only 2 hydrogens because it already have 2 bonds. The third carbon here, it doesn't need any hydrogen because it has 3 bonds. The fourth carbon, it needs 2 hydrogens. And the last carbon needs 3 hydrogens. So this is the correct structure for 3,3-dimethyl pentane. Okay, so let's go to question number 17. It says give the condensed structure formula for the following. So the same question, but this time it needs us to draw the condensed structure formula. So the condensed structure formula, we don't show the bond between the carbon and hydrogen. The first one is 2,2,4,4 tetramethylpentane. As I said, we have to start with the parent. The parent is pentane. It means we have 5 carbons there. So I go back here, question number 17. The parent has 5 carbon. 1, 2, 3, 4, 5. Okay, so these are 5 carbons. And what are my branches? It says in the second and in the fourth position, we have 4 methyl, tetramethyl. So we have 4 methyls. The location of them, 2 of them are in the second position and 2 of them are in the fourth position. So I add the methyl in the second and fourth position in my parent hydrocarbon. So here I number my hydrocarbon. This is carbon number 1, carbon number 2, 3, 4, 5. I add 2 methyl in the second position, CH3, another methyl here, CH3, and 2 methyls in the fourth position, methyl here, methyl here. Now I must add the hydrogen to the rest of the carbon. The first carbon needs 3 hydrogen, so I write CH3. It's connected. This carbon doesn't need any hydrogen, carbon number 2. Carbon number 3, it needs 2 hydrogens, so I write CH2. Carbon number 4, it doesn't need any hydrogen, it has already 4 bonds. But the last carbon, carbon number 5, it needs 3 hydrogens, so I write CH3. So in the condensed format, you don't show the bond between the carbon and hydrogen. So this is the condensed. This is condensed structure formula for this molecule. Question number 17. Let's move on to question number 18. It says for each of the following, determine whether the alkane is named correctly or not. If it is not, give the correct name. So several names of the alkane is given here. So you can see the end of them is A and E. So it means they are alkane. But it asks us if the name which is given is correct or not. To identify if the name which is given here is correct or not, you have to draw the molecule as it's given to you. Then you can check if it's correct or not. So let's do question number 1 as an example. Part A, it says 1-methyl propane. So you know that the propane means 3 carbons. So I draw 3 carbons here. 1, 2, 3. On the first position, it says I have methyl. So on the first position, I put methyl, CH3. Now I add the hydrogen to rest of the carbon. This carbon, which is here, it needs only 2 hydrogens, so it becomes CH2. The next carbon also needs 2 hydrogen, it becomes CH2. The next carbon, or last carbon, needs 3 hydrogens, CH3. So this is the structure of this one. Is this correct name for this structure or not?
Can we say just like butane? Take it all as the chain?
Yeah, so all of them are actually in a straight chain, this one, okay? So this is the hydrocarbon, this is the alkane, which doesn't have any branch at all. So on the first position, you cannot have the branch, because if you have anything here, it's included in the parent. So the name was wrong because they took this one as the longest chain and as a parent, and they took this one as a branch. But you can see that we can find the longer chain than this one, this blue one. Okay? So this compound is actually butane. So the correct name is butane. So the first name is wrong. For part B, says no name without any branch. Is this correct? Yeah, obviously this is the correct. Nonane is a hydrocarbon which has 9 carbons. So the nonane is CH3 connected to CH2, 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 CH2. Okay, you can show the bond between the carbons. 1, 2, 3, 4, 5, 6, 7, 8, and the last carbon needs always 3 hydrogen, CH3. So this is the no name. This name is correct. Okay, let's do the part C. It says methyl hexane, 4-methyl hexane. So for the hexane, we must draw 6 carbons. So 1, 2, 3, 4, 5, 6. And it says in the 4th position, I have hexane. So I number my parent. Let's this one be carbon number 1, carbon number 2, carbon number 3, 4, 5, 6. Just on the 4th position, I have methyl here, CH3. Now I add the hydrogen to the rest of the carbon. Carbon number 1 needs 3 hydrogen. So CH3, carbon number 2 needs 2 hydrogen. CH2, the next carbon needs 2 hydrogen as well, CH2. Carbon number 4, it has already 4 bonds, so it needs only 1 bond with the hydrogen, so it needs 1 hydrogen, CH. Carbon number 5, it needs 2 hydrogens, CH2, and carbon number 6 is CH3. So is this correct name for this structure or not? Any idea? The longest
It's not
chain
correct.
is not correct.
I
What's the
think
problem?
it has to be a 3-methyl hexane.
Exactly. It has to be 3-methyl hexane. Actually, what they did wrong here is the numbering of the parent. If you number the parent from the left side, the methyl is in the position number 4. But if you number the parent from the right side, 1, 2, 3, 4, 5, 6, the methyl is in the 3rd position. So the correct name for this structure must be 3-methyl hexane. Okay. So again, this naming is wrong, and the correct name is 3-methyl hexane. And the last question, part D, says 4-ethyl 2-methyl hexane. I have hexane, it means I have 6 carbons here. So 1, 2, 3, 4, 5, 6. I give some space for adding the hydrogen. So I have to number it. I number it from the left side. This is carbon number 1, carbon number 2, 3, 4, 5, and 6. It says in the 4th position I have ethyl. So in the 4th position I add ethyl. The ethyl is CH2, CH3. This is ethyl. And it says on the 2nd position I have methyl. So on the 2nd position I have methyl, which is CH3. Let's add the hydrogen to the rest of the carbon. Carbon number 1, it has only 1 bond with the carbon, so it needs 3 hydrogens. Carbon number 2 needs only 1 hydrogen. Carbon number 3 needs 2. The 4th one needs 1. The 5th one needs 2. And the last carbon needs 3 hydrogens. Okay, so is this correct name for this compound? The pattern is chosen correctly. This is the longest chain. And the numbering is also done correctly. From the left side, you have to number the parent, because if you number the parent, the first branch, which is methyl, appears to be in the 2nd position. But if you number this compound from the right side, this would be carbon number 1, this is carbon number 2, this is carbon number 3, and the first branch appears at the number 3. So from the left side is correct system of numbering. Okay, so any problem in the naming of this? No, there is no problem. When you want to write down the branches, first you have to write the branches which has alphabetical priority. The E ethyl comes before M methyl. So first you have to write ethyl, and the ethyl is in the 4th position, so it's 4-ethyl. And the methyl is in the 2nd position, 2-methyl, and you have 6 carbons in the parent, so it's hexane. So this one is correct name for the compound. Let's go back to section 2, and this time I want to talk about the next hydrocarbon, which is alkene. So you know that the alkene is the hydrocarbons which you have the double bond. So we want to talk about the alkene on page 690. Says the alkenes are hydrocarbons that contain double covalent bond. So in the alkene, you have a double bond between the carbon and carbon, as you can see here. So here I want to write down the alkenes, E-N-E, okay, it has E-N-E at the end. Same as the alkane, I want to draw the structural formula here. And then I will draw the molecular formula. And then I give the name of the alkene. Okay, the first member of the alkene must have two carbons. In the alkane, the first member had only one carbon and it was the methane. But in the alkene, because we must have the double bond between the carbons, we cannot have only one carbon. So the first carbon in the alkene, or the first member of the alkene homologous series, has two carbons. So carbon connects to another carbon by the double bond. Now I have to add the hydrogen to each one of them. Each carbon here has two bonds. Actually, it has one double bond. So it needs two more bonds with the hydrogen to become octet. So this is the structural formula for the first alkene. This is uncondensed structural formula. The condensed structural formula, we don't show the bond between the carbon and hydrogen. So it would be CH2 double bond CH2. The molecular formula, you have two carbons, and how many hydrogens you have here? You have four hydrogens. What is the name of these alkene? The name of the alkane with two carbon was ethane, A-N-E. When you have the double bond, this A-N-E here converts to E-N-E. So the correct name for this one is ethene. So you can see the stem of the name is exactly the same as the alkane. That's why I said the alkanes are very important, because they form the base format for the naming rest of the organic molecules. The only difference between these molecules, the alkenes and alkane, is the end of the molecule. In the alkene, we have to write ENE. In the alkane, it was ANE. Let's go to the next member of the alkene. The next member of the alkene has three carbons. So I put carbon, double bond, carbon, single bond carbon. Only having one carbon is enough. One double bond between the carbon is enough to be alkene. The first carbon needs two hydrogens. The second carbon, it has shared three electrons with the rest of the atom, so it only needs one hydrogen. And the last carbon, which has only one single bond, needs three hydrogen. The condensed formula for this one is CH2. It has double bond with CH, and CH has a single bond with CH3. The molecular formula for this compound, you have three carbons, and if you count the hydrogens here, the hydrogens are 6. So it's C3H6. And alkane with three carbon was propane. Here it becomes propene, E-N-E at the end. Okay, let's go to the next member of the alkene homologous series. It must contain four carbons. So I write carbon, double bond, carbon, single bond, carbon, single bond, carbon. I put the hydrogens here. The first carbon needs two hydrogen. The second carbon needs only one hydrogen. Then you need two hydrogens here. And for the last carbon, you need three hydrogens. The condensed structure of this one is CH2, double bond CH, single bond CH2, single bond CH3. The molecular formula, you have 4 carbons, C4, and the number of hydrogens in this structure are 8. The name of this one is butene. Okay, you can guess what would be the next of the next member. The next member is pentene, because from 5 and onward, the name comes from the Greek number, pentene. So in the pentene, I just draw the condensed structure formula for that. It's CH2, double bond CH, and you have CH2, CH2, CH3, 5 carbons with 1 double bond. You have 5 carbons. If you count the hydrogen in this structure, it would be 10, and so on. Then you have hexene, heptene, and so on. Okay. Again, in the alkene, can you find any relationship between the number of the carbon and hydrogen in each of these compounds? The relationship between the number of carbon and hydrogen.
They're doubled, so
They
2
are
times the number of carbons.
exactly. So the general molecular formula for alkenes are CnH2n. Okay. So if I want to write the molecular formula for alkene with 30 carbon, it would be C30H twice as the
60.
number, 60. Okay. So this shows that you have the alkene. But if it was like this C30H62, this one is alkene.
Alkane.
Yeah, this one is alkene. So in the alkene, the general formula is CnH2n. The number of hydrogen is twice as the number of the carbon. But for the alkane, the number of hydrogens is twice as number of carbon plus 2. So if the molecular formula is given to you, based on these two general formula and the relationships which you have between the carbon and hydrogen, you can identify if this molecular formula is for alkene or for alkene. Okay, but let's go back here to butene. In this structure which I have drawn here, I have put the double bond here on the first position between the carbon and carbon. But I can also draw another alkene with exactly the same molecular formula, C4H8, but the position of the double bond would be at the middle of the carbon. So compare this one with this structure. Suppose you have carbon, single bond with carbon, double bond with the carbon, single bond with another carbon. And if you want to put the hydrogens, you need 3 hydrogens for the first one. For the second one, you need only 1 hydrogen. For the third one, also you need only 1 hydrogen. And for the last one, you need 3 hydrogens. If you count the carbon in this structure and the hydrogens, there are 4 carbons and 8 hydrogens. So the formula for this one is also C4H8. And let's draw the condensed formula for that one. It would be CH3, CH, double bond, CH, CH3. So this one is also butene. But 2 different molecules. So they are isomers of each other. Okay, the arrangement of the atom and the location of the double bond is different from each other. So they are isomers of each other. So you know that the isomers are 2 completely different molecules. So you have to have different name for each one of them. So here again we go to the system of the numbering. We have to number these hydrocarbons, these alkenes. But for the alkenes, you must number your parent chain from the side which double bond receive smaller number. For the first one, If I number it from the left side, 1, 2, 3, 4, the double bond would be between the first and second position. For this molecule, if I number it from the right side, this would be number 1, number 2, number 3, and the number 4. And the double bond would be between carbon number 3 and number 4. So as I said, for the alkene, you have to number your parent chain, or if you have a straight chain, your straight chain from the side which double bond receive a smaller number, not the branch. So the priority is with the double bond, not with the branch. Here we don't have the branch, so we number it from the side which the double bond receive a smaller number. So the first position which double bond appears is in the first position. Actually, it's between the first and second position, but the first it appears after the first carbon. So we say this is 1 butene. This 1 refers to the position of the double bond. E and E represents the double bond. For the second one, if I number it from the left side, this is carbon number 1, this is carbon number 2, 3, 4. And the double bond appears to be between carbon number 2 and number 3. So it's actually in the carbon number 2. If I number it from the right side, this would be carbon number 1, carbon number 2, carbon number 3, carbon number 4. Again, from the right side, the first position which the double bond appears is in the second position. So for this molecule, there is the same if you number it from the left side and the right side, no matter from which side you number it, because from both sides, the double bond first appears to be in the second position. So this molecule is 2-butene. So 2 refers again to the position of the double bond. So for the alkene, the position of the double bond also must be mentioned there. Okay? So you have to write 1-butene or 2-butene. But some of the textbook, they write like this. They write but 1-ene. Okay, so they write 1 before E and E. So it means the double bonds are in the first position. So you can choose any system of the numbering here. Your book use this one. It's written 1-butene. But actually this one is more correct. But 1-ene is more correct name for that one. But both of them are acceptable. So if I want to write the more correct name for 2-butene, I have to write but 2-ene. Okay, again it means the double bond is in the second position. So 2-butene and but 2-ene are exactly the same thing. So you can use one system for yourself. And as I said, your book uses the first one. So your book written 2-butene. Okay, so what is the name of this one? Again, in the pentene, the double bond which I have written here are on carbon number 1. This is carbon number 1, 2, 3, 4, 5. But this double bond could be here in this position or here in this position. So you have to mention the location of the double bond is on the first carbon. So this molecule, this specific pentene is 1-pentene. Or you can write it's pent 1-ene. Okay, any question regarding the naming of the alkenes? Our time is almost finished, but I want to talk for just 2 minutes about the propane. So look at the position of the double bond. I can also put the double bond here on between carbon at the middle and the carbon at the right. So I can write CH3 single bond CH double bond CH2. This one also you have 3 carbons with 1 double bond, so it's propane. But why I don't put any number here for propane? Look at this one. For the molecule which is written here, if I want to number it, I have to number it from the left side. because the double bond is at the left of the molecule and it receives a smaller number. So this compound is actually 1 propene. For this molecule, I have to number it from the right side because the double bond is at the right side. And if I number it from the right side, double bond receives a smaller number. Again, the double bond is on the first position. So this one is also 1 propene. So it means these two molecules are actually the same molecules. The only difference between these two molecules is that we have rotated the molecule. Okay? When you rotate the molecule, these double bonds comes here. So these two molecules are exactly the same, and we have only 1 propene. That's why for the propene, usually we don't mention the position of the double bond because there is only 1 position for the double bond. So you can just name it propene. Although if you write 1 propene, it's not wrong, but it's not common to mention the position of the double bond when there is no difference where is the position of that. So this one is propene.